Breaking ADC linearity. Using an external op-amp will show you how to reduce differential linearity errors and improve resolution. Oversampling and averaging increases resolution but does little for differential linearity errors. For a 3.2 volts full scale, this 10-bit ADC should have no more than plus and minus 1.6 millivolts of error. At the cost of speed, we can correct some of the deficiencies by using a delta sigma converter configuration. The input uses an analog integrator to average noise. After the integrator output is converted using an ADC, it is fed back and subtracted from the input. Those familiar with op-amps will note this is a voltage follower. The digital data dithers about the input value. A simple IIR, or infinite impulse response, low-pass filter removes the dither noise. Here is a circuit for testing a Raspberry Pi Pico. The 3.3 volt regulated out is filtered to reduce noise. U2A is the analog summing integrator. It is biased at 1.65 volts for bipolar inputs. U2B is the sink for the negative input. U2C is a ramp generator used to test linearity. The measurement of the test ramp is least squares fit to a linear curve. Subtracting the curve from the measured data yields the linearity error. By fitting a fourth-order curve to the error, the polynomial can be used to flatten the linearity error. After applying the fourth-order correction, total linearity is reduced to about plus and minus 0.8 millivolts. Additional noise reduction is possible by increasing the value of C5. The 0.001 microfarads value for C5 was selected as a compromise for the upcoming RMS measurement. Measurements of a small signal triangle wave with 5 millivolts DAC steps. The delta sigma configuration shows improved linearity with respect to averaging. Root mean square is a value that represents the DC heating value of an arbitrary voltage. Common RMS values are 0.707 times the peak sine wave voltage, 0.577 times the peak triangle wave voltage, and equal to the peak square wave voltage. By squaring the output of the ADC, the delta sigma converter's IIR filter will pseudo-integrate the result. Taking the square root of the filter output returns the RMS value of the input signal. Here are 3 1-volt peak input waveforms shown as the green traces. The square wave has the most error due to the slow rising and falling edges of the analog integrator. Blue waveforms are for the integrator output. Want to experiment with delta sigma conversion? Here's what you'll need. Project resources can be found at github.com Simple Circuit Breaking Linearity. Adios.